All right, number 13 is negative 6a cubed minus 4a squared plus 2. Again, I'm just giving you some of the answers. Jump down to 19. 42p to the third plus 24p squared. 21 is 14x squared minus 19x plus 6. 23 is 12n squared minus 35n plus 8. 29 is 18n to the third minus 47n minus 20. 31 is 15k to the third minus 40k squared plus 35k minus 10. 36 is x squared minus 10x plus 25. 37 is d cubed plus 9d squared plus 27d plus 27. 38, t cubed minus 21t squared plus 147t minus 343. Jumping to 41, 47z cubed minus 27z squared plus 9z minus 1. And last one, 27w cubed plus 108w squared plus 144w plus 64. So I will say that if you got them mostly right, but maybe only one or two in the problem were wrong, it may be just careless error, adding incorrectly, putting a negative where there wasn't one, just, human error. But are there any of these that you guys want me to go over? Or any of them even that we didn't get answers to? We don't have to go over anything. If you're good, you're good. You good? Awesome. Okay. Abby, do you have anything?
No, ma'am.
All right, cool. Abby, it's just you, me, Mason, and Bryce today. That's it. All right, well, I'll chalk it out paper for notes. And I'm recording this for all those at home who are not here. Oh, by the way, we are having a quiz on Monday over what we did last time and then what we're doing today. Okay, so quiz on Monday over add, subtract, multiply, and then factor and solve, which is what we're doing today. So we're going to factor and solve polynomials. Factor and solve. There are 4 ways that I'm going to talk to you about factoring. Of course, so far we've done some factoring and we've kind of only done 2 things. We've had a trinomial, and so that's where we do the first times last, sum of the middle number. And then we've had difference of squares. And those are the 2 ones that we've had so far. So we're kind of building on top of that. We're going to use those, but then we're also going to do a few other things. Polynomials, remember, are bigger than trinomials. Can be. They've got higher powers, so we're going to need more tricks. But no matter what, first thing we're going to do is find a common monomial, if there is one available. And that's what I'm talking about when I say greatest common factor. Greatest common factor, that's what we're looking for. I call it common monomial. I think I'm just so used to saying it. Mono means one, so one term that we're pulling out that's common to everything. Always what we look for first. So let's say we have x cubed plus 2x squared minus And so what would be common to all three of those? Yeah, there's an x in there. So I'm going to take the x out. And let's write down the leftovers. What's left over when you pull out x? Perfect. All right. Then you're going to check whatever you factored, whatever's left over, and see if you can factor that. So we're going to try and factor this. We have to check it. 1 times negative 15 is negative 15. I need a sum of 2. Oh, you're so close. There you go. And while I'm factoring this trinomial, I'm going to go ahead and ignore the x for a minute. We'll bring it back later when we need it, but I'm just going to worry about this trinomial at the moment. So x squared plus 5x minus 3x minus 15. All right, what comes out of that first bracket? Which leaves us with? Good. And the second bracket? Good, which leaves us with? Perfect. So now I have x minus 3 and x plus 5. But don't forget about that x. Remember that x we took out earlier? Don't forget, you have to bring that down. And that also goes in front of that trinomial that you factored. So your answer includes the x. And that's the part that you got to watch out for. That's where I usually see the mistakes happen on this, is you just forget to bring that monomial back down.
So you don't have to say equal 0 and solve it.
We will at the end. That's the why we're doing all of this, but we are going to solve at the end. Yep. So just read the directions. It depends. If it says factor, you just factor and you stop. If it says solve, you have to keep going. All right, I want you to factor 2y to the 5th minus 18y cubed. All right, what did you use for your common monomial?
2y
Good. Which leaves us with?
1 squared minus
Perfect. Okay, does that y squared minus 9 look like it could be something? It is. It's, go back and remember, difference of squares. Now, difference of squares will come up all the time from now until you're done with math. Like, it's just a very popular thing that needs to be factored. So if I have y squared minus 9, remember difference of squares, you think, okay, it's a difference. Y squared is a perfect square. What's the square root of y squared? Y, good. And 9 is a perfect square. What's the square root of 9? 3. And then you remember it's 2 different parentheses. Y goes at the front of both. 3 goes at the back of both. And then 1's plus and 1's minus. And that's how you factor a difference of squares. Don't forget to bring down your 2y cubed. Difference of squares only works if it's a perfect square. So if you have y squared minus 7, you would not factor it any further. It only works when you got a perfect square. Okay, so that's a common monomial. That's always what you look for first, no matter what. Now let's look at a couple special patterns. So the rest of these is what you do after you get your common monomial. One of the special patterns is difference of squares. There's another one we use when we have perfect cubes. And there is both a sum and difference of cubes. That is the different thing about that. So let's start with a cubed plus b cubed. All right, again, it only works for perfect cubes. And then it works for both a plus and then I'll also give you the minus. So it works for both of them, but they have to be perfect cubes. And you know how yesterday I said you don't have to memorize those special patterns? Yeah, well today these do have to be memorized because there's only one way to factor them and that's doing the patterns. So this is going to be a plus b is the first factor. The second one is a squared minus ab plus b squared. A squared minus ab plus b squared. Now I'll tell you this trinomial is always going to be prime. It's always going to be prime. Prime means it does not factor. So whenever you factor a sum or difference of cubes, you're going to have a trinomial that does not factor in it. Now let's talk about the signs. You do have to kind of memorize this pattern, but the signs are going to be memorized using the acronym SOAP. Okay, that's how we get our signs. S stands for same sign. So the first sign is the same sign. If you're given a plus, you've got a plus here. O stands for opposite sign. So the second sign is opposite of what you were given. And then the AP stands for always positive. And that's the last sign. Last sign is always positive. So it's same sign, opposite sign, always positive. So let's do one. We're going to factor 8x cubed plus 27. All right, so let's say I'm not 100% sure if they're perfect cubes, but I do know that this one is cubed, so that should be your clue to check and see. If they are not perfect cubes, I would say try and find a common monomial that pulls out first, so then you might end up with some perfect cubes. But on these, we know that 8 is a perfect cube, so here's what you need to do. Take the cubed root of the first term. And what's the cubed root of 8x cubed? 2a, good. Or 2x, sorry, 2x. And then take the cubed root of the second term, 27. What's cubed root of 27? 3. Oh, I'm going to bring that back down. There we go. All right, so in our pattern, the cubed root, notice you're given a cubed, and in the pattern, everywhere there's an a, we're going to use 2x. That's going to be our a. And 3 is going to be our b. So you have to take the cubed root to figure out what a and b is in the pattern. And then you're just going to sub it. Everywhere there's an a, you're going to use 2x. B is 3. So our pattern's going to be a plus b. 2x plus 3. Times a squared, so 2x squared, minus a times b plus b squared. And if you can do it in your head, that's fine. So let's finish that up. What's 2x squared? Good, 4x squared. Because you have to square both of them. So you have 4x squared minus 2x times 3 is 6x. And what's 3 squared? All right. You could not factor that trinomial because 4 times 9 is 36. I need a sum of -6. There's no combination of 36 that will add up to -6. This one's always going to end up being prime. All right, questions so far? Okay, so the difference of cubes is the exact same pattern, only you got to use SOAP for the signs. So the pattern is still A and B, and then A squared, AB, B squared. Same pattern. First sign is the same sign as what you're given. Second sign is opposite. Last one's always positive. So really you only have to memorize one pattern, and then if you know SOAP for the signs, you're good on both of these. So I want you guys to do by yourself 64x cubed minus 1. Factor that. 64x cubed minus 1. All right, first thing I would do is it's got a cubed on it, so let's see if it's a perfect cube, and it is. What's the cubed root of 64x cubed? Good, and that's going to be your A. And then the cubed root of 1 is 1, and that's going to be your B. So we're going to have A minus B times A squared plus A times B plus B squared. Okay, what's 4x squared?
16.
Good. 4x times 1 is 4x, and then 1 squared, of course, is 1. Our book and our workbook seem to be really fond of this. They love difference in sum of cubes. Because if I was solving, and we're about to get to solving, and we know we just talked about that, how we set them each equal to 0 and solve. But if I have a prime one that does not factor, how would you have to solve it? What would you have to use? Okay. Those are your only options. So anytime you have a difference or a sum of cubes and you're solving, you have to, with this thing particularly, you have to do quadratic formula or completing the square to get those, because it's prime. It's not ever going to factor. Okay, so that's special patterns. The next one is factor by grouping, which we are kind of experts at this point. But we're going to do it with some polynomials. So we're talking about things specifically that are going to be 4 terms so that I can do my groups of 2. Trinomials, we split that middle term and turn it into 4, and then we do our grouping. So this is really not going to be anything new for us. So let's do some grouping with ones like x cubed minus 3x squared minus 16x plus 48. So you've got 4 terms. You're going to check and see, is there any common monomial? No, there's no common monomial. So we're going to try grouping. So for grouping, you're going to do exactly what we did with trinomials, group them into groups of 2. And then what can factor out of this first group here? Yeah, x squared this time, which leaves you with, good. What would come out of that second group? You're right, which will also leave us with x minus 3. Then same thing like before, we take x squared minus 16 as one of our factors and x minus 3 as the other. So it's exactly like factoring a trinomial, only this one's already split apart into 4 terms for you. Now, before I'm done, check here and see if there's anything else that can be factored. So I'm going to say check for more, because usually with grouping, not always, a lot of times you'll see something else that might work. Do we see something else that factors? Do you see it? Perfect square, minus, difference of squares. Yeah, it'll come up a lot from here on out. So how do I factor x squared minus 16? What does that become? Perfect. And then bring down the x minus 3, and there is your fully factored polynomial. So when you get done with things like grouping, you got to double check. If it's not a perfect square, again, you don't have to do that, but always check. So I'm going to let you do one by yourself. 27t cubed plus 45t squared minus 3t minus 5. Factor completely. Are you ready? Okay. All right. So we're going to group. All right. What did you get come out of your first group, Mason?
9t squared.
Perfect. 9t squared. What'd you get left over?
3t minus
3t. Careful on the sign there. Plus 5. And that's almost what I want in this parenthesis or this bracket right here. So we're going to pull out a -1 there to give us the 3t plus 5. Make sense? Okay. So now we have 9t squared minus 1 and 3t plus 5. Did you see anything there that was special?
9t squared.
Good. That is a difference of squares. All right. What did you get when you factor that?
3t plus 1, 3t minus 1.
Perfect. So that's the 9t squared minus 1. That's difference of squares. Bring down the 3t plus 5. All right. Any questions so far? Okay, so then the next method, that's the fourth one. So this is, or the third one, this is the fourth. This is the last of the factoring methods. And that's whenever you have something that's just x to the fourth, x squared, and a constant. You have 3 terms, but your powers are a little different than what you're used to seeing. It'll be in the form of x to the fourth, x squared, and then a number. And for that, we're going to use the substitution method. Substitution method. So we're going to do one. That's the best way to learn this. Let's say we have x to the fourth minus 3x squared minus 4. All right, so what we're going to do here is I can do factoring with a trinomial, right? Like we've done first time class, I use some of the middle number. But this has, instead of a squared and an x and a constant, it has a fourth and a second and a constant. So what we're going to do is whatever's in the middle, that x squared, we're going to sub x squared, and we're going to put an a in its place, because that's what we're used to having there. Now, you can use any variable. Usually if I'm given the end of the alphabet like an X, Y, Z, I'll sub with an A, B, or C, and vice versa. That way I'm not getting things too confused. But pick a variable you want to sub. Now, x to the fourth. X to the fourth, would you agree that that is x squared squared? Does that make sense? Okay. Yeah, because it's just breaking it apart so you can see it individually. Well, if I sub x squared with an a, this is now a squared. So we're replacing x squareds with a's. So then when I go back and I'm doing this x to the fourth, I'm going to change it to an a squared minus 3a minus 4. So now you can factor like we normally would. Factor like a typical trinomial. 1 times -4 is -4. I need a sum of -3. Good, -4 and 1. And we're going to stick with our a's for right now until we're done. Bryce, does the substitution make some sense?
Yes, it is.
Okay, I'm just changing x squared out for a. X to the fourth is a squared. Okay. All right, doing our normal grouping here. I can pull an a out of the first group, which leaves a minus 4. But what am I going to pull out of the second group? Yep, just a positive 1 because that's exactly what I want. And then I'm going to have a plus 1, a minus 4. Now, the trick is going to be don't leave it like this because that's not what we started with. So right here when we get to this part, we're going to sub back the a equals x squared. We're going to replace our a's back with our x squares again. And then, of course, now we got our x squareds back. Check for more right here because this is where you might find something else. And do you see some more that we can factor? Yeah, x squared minus 4, there's a difference of squares. What does that one become? Perfect. X squared plus 1 is nothing of note, so we're just going to bring that down. And we're done. All right, I want you to try one. X to the 4th plus 7x squared minus 18. Our book is very fond of these as well. It's funny what this particular book chooses to find important. And just a side note, just for FYI informational purposes, I can use it with a 4, a 2, and a constant. You can use the same method with a 6th, a 3rd power, and a constant. Anything where the first power is double of that of the second one. So you could do x to the 8th, x to the 4th, and a constant. I don't think those are in the book. I don't think those come up, but just an FYI, same concept applies. Kind of cool. All right, give that one a try. All right. And, okay, so x squared turns into a, which means x to the 4th turns into a squared. And then factors of negative 18 that add up to 7. Good. So now I have a squared plus 9a minus 2a minus 18. All right, what comes out of the first bracket? Which leaves us with, good, and the second bracket, which leaves us with, good, so now you have a minus 2, a plus 9. We're going to sub back into our x squared. And are either of those a difference of squares? Careful, it's not a difference though. Yeah. And this one is a difference, but it doesn't have a perfect square. So that's as far as you have to go. That's it. Okay, so the whole y, of course, is to solve. That's why we're learning to factor. To solve. So when you're solving, just like in quadratics, you're going to factor first. Then you're going to set each factor equal to 0 and solve. Just like quadratics. Factor first, then set each factor equal to 0 and solve. So let's talk about a couple of these and then we're almost done here. Oh, you'll get some good time to get some work done. 2x to the 5th plus 24x is equal to 14x cubed. That's what we're going to start with. Okay, first of all, before I can do anything, you have to get this equal to 0. That's always the first thing to do. So what should we do?
Subtract 14.
Yep, perfect. So 2x to the 5th minus 14x cubed plus 24x is now equal to 0. Okay, so now this is where you factor, and I'm going to give you some time to do that. Don't worry about the solving yet. Let's see if you can factor completely as far as you can go. Remember, don't forget to start with a common monomial always first. It's always the first thing you look for. All right, what are we going to take out of this first? Yeah, let's take out a common monomial, 2x, which leaves us with, whoops, get Okay, so then the thing that's left over on the inside is going to be one of those with a substitution. So we're going to sub this for a squared, this for a, plus 12. And we're going to ignore that 12x for just a minute, but you can't forget about it in the end. So don't forget about it. But let's go ahead and factor this. So I need a sum of -7 factors of 12 that add up to -7. -4 and -3. A squared minus 4a minus 3a plus 12. Good. Right there, what comes out of the first group, which leaves us with a minus 4. And the second group, good. That leaves us with a minus 4 also. So now we have a minus 3, a minus 4. Convert back to x's. Don't forget that part. So x squared minus 3, x squared minus 4. I see a difference of squares. Did you see it? So what does x squared minus 4 become? Good. And then I have this x squared minus 3. But then go all the way up to your 2x and bring it down as well. Because that common monomial that got brought out, if you forget it, it's going to affect your final answer. So don't forget that. That's one of the most common mistakes I see on this part. Whew. Now, we got to set each one of these equal to 0. So 2x equals 0. X squared minus 3 is equal to 0. X plus 2 is equal to 0, and x minus 2 is equal to 0. And then solve each little problem. So 2x, we're going to have to divide by 2. X is what? 0. This one, what are we going to do? Add 3. So x squared is equal to 3, and then root both sides. So x is equal to, perfect. This is actually two answers, positive and negative square root of 3. And then here I'm going to subtract 2, so x is equal to, perfect. And plus 2 right here, x is equal to 2. All right, I actually have 1, 2, 3, 4, 5 answers. Now with polynomials, whatever your highest power is actually the maximum number of answers you're going to have. So I could have up to 5 answers. We'll look more into it in the future as to all that, how many there can be. But there's 5 here, and that's what we're allowed, so we're good. Sometimes you'll have less, so don't worry about if you don't get all of them. All right, this last one, we're not going to make it all the way on this one, but I just want to discuss it. So you're going to be asked to solve 3x to the 4th minus 6x cubed plus 12x squared. And what I want you to do is go ahead and factor. Do the factoring part on this. what are you pulling out of this first? 3x. Good, a little bit higher. So then you're left with x squared minus 2x plus 4. Is that what you got? Okay. Now, are you trying to factor that trinomial? What's going on with it? Not working, right? I need 1 times 4 is 4. I need a sum of -2. There's no factors in -2 that add up to 4. So this one's prime. And whenever that happens, I mean, we're done as far as the factoring portion of this. What we would do next is set 3x squared equal to 0 and solve. And the trinomial equal to 0 and solve. Only I can't do any factoring there. So my only choices, if it's not factorable, remember it's quadratic formula or completing the square. And if you're not going to remember what those mean, you might want to write that out. You have two choices now. So you have to do quadratic formula on this one or completing the square, whatever you like. Always reduce your radicals, reduce your quadratic formula, final answer. And that's where you have to go there, okay? So we're in our workbook today, remember? And then on Monday, bring your book. We'll start in the book on Monday. We're going to do 1 to 15 odd. 31 and 32, show all your work. And don't forget, we have a quiz Monday. Quiz on Monday. And that's going to be over what we did yesterday and what we've done today. So, Abby, unless you have any questions, you're free to go, and I'll see you on Monday. Stop this.